Hey, composites. So ACP, Ansys Composite Prep Post, composites and mechanical, and Ansys Composite Cure simulation. In ACP, there's a new feature for automatically generating beam properties based on a composite layup. So if you have a thin structure, like say a slender structure, like say a turbine blade, and you want a beam representation of that for some simulation model, and you don't want to necessarily include the whole shell mesh with the built-in composite layup definition generated in ACP. ACP has this feature now to automatically generate the beam properties for this thin structure, which has been laid up in, say, carbon fiber or glass fiber or what have you. So it automatically extracts those properties. At the moment, it's limited to individual snapshots along the length. So if you have a beam structure that varies in cross-section like this, what you need to do is take multiple samples along the length, and then that will generate separate beam definitions, and then you tie them together by applying them to separate or tied beam elements in your mechanical model. The next enhancement, which is available, which will be in 2025, is to do a continuous beam extraction. So it will automatically extract the beam properties along the whole length of the blade and apply that to your beam element. There's a winding wizard too. So this is for pressure vessels, not submarines. So if we're doing, say, mandrel or pressure vessels with sort of wrapped, what's the word I'm looking for? Escapes me now. But anyway, if we're doing a pressure vessel in, say, carbon fiber, we wrap the fibers around using sort of an automated process, and simulating this can be really tedious because you can see the fiber direction changes a lot as it wraps around specifically the dome ends of this structure. So at the moment, this winding wizard is just for simple geometries like this cylinder. If you have very complex wound composite parts, you would use a specialized tool which can generate, like CAD-Wind or CAD-Fill, and they can generate input file that you can import into ACP and automatically defines your composite layup. But this winding wizard is sort of just to do simple structures and initial designs before you get a bit more complex. Some enhancements for reinforcing plies on solid meshes. So we can generate a solid mesh representation of a composite in ACP, but it often doesn't represent exactly the geometry we want, and we can't put in reinforcing layers, but we can do that now. So if you have a solid representation of your composite part, you can define a layup for that in shell elements, and then that layup gets mapped onto your solid mesh. So now you have a solid mesh representation of your composite, which matches your manufactured CAD perfectly. And we can also insert these reinforcing layers. So if you have reinforcing layers of some particular type of fiber or metal layer or something like that, that can get inserted with this reinforcing tool. And for Elastina, ACP now supports a whole bunch more composite materials. Elastina has tons of composite materials. So previously it only supported 2 of them, matte composite damage and one other one. Now it supports matte 54, 58, 59 for shells and solids. And there's also a whole bunch of material models added to engineering data. So you can go into engineering data in the sample libraries, and there's data for these material models. So these material models tend to have a lot of parameters involved with them for things like, say, damage prediction, post-damage softening effects, anisotropic or orthotropic properties, and also different behaviors in tension and compression post-failure. So that's where you might want to select these models for those applications. So now they're available through ACP. And speaking of ACP, ACP Post is going away. So this is the last release that'll have ACP Post. So previously, what we would do is set up our composite in ACP pre, feed that into mechanical, and then do all the post-processing of damage criteria, inverse reserve factors, all that sort of stuff there. That's gone away because it's clunky, not really nice to use, and all of that capability has now been added to mechanical. So everything you could do in ACP post, you can now do in mechanical, and it is a lot easier, a lot faster, and less remembering of particular clicking steps that you had to do to get the particular contour that you're after. It's much easier to do in mechanical now. So as of 2025 R1, that'll be gone. And also the data processing framework is inheriting a lot of the ACP post capability. So if you want to get into customizing or building your own composite post-processing features, you can use the DPF for that. Dwell on that. Oh yeah, and the PyACP is the first release for that. You could always do a lot of Python scripting in ACP because it's a Python-based interface, but now you can automate the whole process by writing Python to generate your entire ACP analysis model. So it's early stages. This is the first release for it, but obviously it's going to improve rapidly. And then the composite cure simulation. So Ansys composite cure simulation is for simulating spring-in effects as the composite cures in the autoclave. So it calculates the shrinkage due to thermal and chemical effects. And you basically give it the whole thermal chemical profile with the history of the curing, and it predicts the shape deformation of the composite due to the resin shrinking. So there's a few enhancements here, support for internal heat generation in the objects, in the curing objects, supporting resin transfer molding. So that's a beta at the moment. And also more materials have been added. The hardest thing about ACCS is getting material properties for it, because there's very complex material properties for predicting the chemical and thermal shrinkage effects. So now there's 6 new resin material properties that have been added into the library to make that whole process a little bit easier. Material Designer. So Material Designer is a tool that was based in SpaceClaim that we use for calculating composite material properties based on constitutive materials. So if we know what the fiber volume fraction is, we know what the fiber properties are, we know what the resin properties are, and we know what our weave looks like, what are the composite material properties going to be. So we would use Material Designer for that. But SpaceClaim is going away and everything's going into Discovery. So a new interface is being developed for Material Designer. And it also supports engineering or experimental stress strain results. So previously, to validate or to define or to validate your composite material, you'd have to give it true stress strain properties, which aren't particularly convenient when it comes from test data. So now you can give it your engineering stress strain data and it will work with that. And then for validation of the composite after the fact, you can compare the results of the validation directly with engineering stress strain instead of having to generate true stress strain. It also supports 3D Tamon now for injection molding, just like it did for Moldex and Moldflow. So if you're doing molding analyses of bulk composite material, so predicting the fiber orientation due to the molding process in 3D Tamon, you can import the results from that directly into mechanical and do your mechanical simulation with that data. AQWA. The AQWA is the hydrodynamics code. So a few enhancements here. In the time domain, AQWA can calculate hydrodynamic pressures on surfaces and Morrison loads on line bodies and pass those to mechanical. So previously, it would only transfer the pressure distribution into the static structural analysis. Now, if we're modeling the structure with line bodies, beam elements, it will calculate the loads for the beam elements and transfer those directly to mechanical rather than having to work with pressures. And also, if we're doing something like a wind turbine on a floating structure, it's quite a complex simulation that involved some extra licensing and other stuff. That's been streamlined and made a bit cheaper as well. So we'd have to do, say, a rigid body dynamics analysis on the wind turbine itself. We would use AQWA for all the hydrodynamic loads, and then that would be fed into a twin builder, and yeah, to solve this analysis. So that meant you have to buy a license for twin builder, which is really expensive. Now you don't need that because system coupling will do that whole job. So that would have doubled the price of the licensing. So you don't need it anymore. They've also upgraded the version of the functional mock-up interface to the latest version.